So the next speaker is it Marilé? Marilé Colón Robles from ADNET and NASA Langley, speaking on the Globe Eclipse project. You got it.
Awesome. So hello, everybody. My name is Marilé Colón Robles. I have a lot of energy because I'm from San Juan, Puerto Rico. And I'll be talking to you about the Globe Eclipse project. This is a team effort that I'm happily here to represent. So I am the project scientist for clouds, which I've been loving seeing all the clouds. Have they been changing around? We are based at NASA Langley Research Center. For every cloud observation that you all submit to the GLOBE program, this team will compare it or co-locate it to satellite data. And within 24 hours, we start sending you NASA personalized emails with your observations and those satellite images as well. So that's our bread and butter. So I'll be showing you a little bit about that. But Ashley Autore is our research support, so a lot of the work that I'll be talking about is done by her. And then the Globe Observer team, without this team, we would not be able to collect observations. So the GLOBE program, I've been saying that a lot. It's been around it's gonna be 30 years next year. It started in 1995 when teachers and scientists came together on ways that K-12 students can make observations of their environment in ways that can be used by researchers like me or do researchers as research based on their communities. It is NASA's largest and longest lasting citizen science program about the Earth, and we do it with NOAA, National Science Foundation, and the US Department of State, because there are 127 different countries that are part of the program, Bhutan being the latest one in the community. In 2016, because of the science activation program that was talked about not too long ago, we were able to release the Globe Observer app, which I'm hoping you all download. I'm watching you, to make those cloud observations and get those satellite data. So we started with clouds because your eyes are your detectors, and clouds change throughout the day all the time. So it's one of the most popular types of observations. So we merged that with now air temperature observations in 2017 and released the Globe Eclipse portion of the app. And in 2017, it was hugely successful, over 80,000 air temperature observations to look at, again, how does the eclipse alter the atmosphere. So with that data, we were able to do a study. On the left, all those dots are volunteers making observations before and after the totality. So blue is clear skies, darker is more cloud cover, and then the temperature observations there. This is a snapshot. If I were to run it, you can see the eclipse. And we were able to see a correlation between total cloud cover and how cool, quote unquote, did it get during the eclipse. Now, when we released this paper, one of the reviewers said, what happens in different climatic regions? So we want to use now these latest eclipses to study what does it happen in different climate regions. So we revamped that portion of the app, and you can see there a snapshot of what it looked like. It'll read your latitude and longitude, so it tells you when is your maximum depending darkness, right? You don't have to be in totality to make observations, and then when to make those air temperature and cloud observations before and after the eclipse. And we worked with a lot of partners. I got to go to the balloon fiesta, which was amazing, but we didn't get as many observations as in the past, especially clustered observations to make those data analysis, statistical analysis that we need. But we still got a lot of good samples. So in preparation, we did an IOP, Intense Observation Period, which we call Cloud Challenges. And for this one was the Eclipse Challenge, Clouds in Our Solar-Powered Earth. We ran it from March 15th through April 15th. Notice the dates. We had the eclipse right in between. Now, when we do challenges, we have to think worldwide. Those 127 different countries. So we did have 90 countries participating, and then that one day of huge peak observations in North America. So for the eclipse, we got about 40,000 observations, or 30,000 air temperature observations, and about 15,000 cloud observations. So there it goes. Okay. So on the day of the eclipse, I don't know about you, but I saw a lot of clouds where I was in Buffalo, New York, so I had to drive southwest and end up somewhere in Ohio, and I found a really nice day because there were some fronts going by. So this is geostationary data of that day. And so we're using these geostationary data, the reports from the volunteers on the ground, and then ASOS, which is Automated Surface Observing Systems, just National Weather Service data. Satellite and people are saying that there was an increase in cloud observations beginning at partial totality all the way up till the end of a maximum and beyond. ASOS is saying the opposite. So we're very interested in that because the satellite data shows that the people are right, which I love, right? I love when I do that. These are the clusters. So this is not all the data that we collected. These are just the clusters where we're doing the statistical analysis. And it's about 15 cities that we're looking in. The blue is the path of totality. And you see all those cities. So in general, all these cities are reporting an increase in high-level clouds, particularly contrails. Who knows what are contrails right here? Oh my goodness, it's the C word. I did say it. Contrails are those lines, straight line clouds that are caused because of the perturbance of an aircraft, because of the heat and the aerosols. So every single site reported an increase in contrails at partial, through maximum, and then afterwards. Contrails are important because they tend to get fatter. You notice that one in the middle photo on the bottom starts getting fatter. They start looking like cirrus clouds, and cirrus clouds tend to warm the atmosphere, complete opposite of cooling the atmosphere. So that's what we're going to be focusing on, right now. So in general, it was a great day of observations unless you were completely total cloud covered, and I'm so sorry about that. Clouds are great, but sometimes they are enemies. We are looking at contrails in those high cirrus clouds, and we're thank you for the balloon project who has already sent us so much observations already to look at the temperature and relative humidity at the top of the troposphere to see what happened. So I'm going to leave my email. If you have any questions, just let me know. Thank you so much.
Thank you, Marilé. Thank you not only for the great talk, but also for keeping to time. All right, so that means we have time for questions. Any questions? Well, I'll start with one. So the Globe app itself is free, right? Will you be doing Globe Eclipse for subsequent eclipses, or is that part of the project kind of done, but you'll just be continuing with clouds?
Oh, that's interesting. So if you download the app, you can do cloud observations, tree heights, which is my favorite. It turns your phone into a clinometer. You can track mosquito habitats and do land cover. We've done eclipses for the 2020 and 2019 eclipses in South America, in Argentina, and Chile. So it depends on the partner countries, like Australia or Spain, things like that, where I know that there's upcoming eclipses if they want to. The app is also available in over 20 different languages, so it is possible to release it. So for this eclipse, we had it in English and Spanish, in French Canadian. So maybe. I'll say maybe. Yeah.
How do you promote the Globe project? How that you're able to get so many people from so many countries?
So NASA promoted us. We were listed as one of NASA's citizen science programs because we're NASA funded. We also work with different partners. So like the Civil Air Patrol collected thousands, like 100,000 observations just themselves. Libraries have been really huge for us, as well as partners for those local communities. So those are just some ideas on how we work. The GLOW program is roots upward. So one person per location, and then they contribute with the community, and then it goes upwards like that. Okay.
Great, thank you very much. Let's thank Marilé again.